What if the Earth were actually flat? Since ancient times, humans once believed that the Earth was flat, a notion stemming from the limitations of human knowledge and observation at the time. However, since great scientists like Galileo, Copernicus, and Newton proved that the Earth is spherical, humanity's perception has profoundly changed, ushering in an era of exploration and remarkable progress. But imagine if the Earth were truly flat. The world we live in would be entirely different. The laws of gravity, climate, and even the existence of day and night would transform in unimaginable ways, creating a completely new and challenging reality. This perspective not only sparks curiosity but also helps us better appreciate the scientific achievements that have shaped the world today. If the Earth were truly flat, the way gravity operates would be entirely different from what we know today. On a spherical Earth, gravity pulls everything toward the center, creating a perfect balance that keeps humans, animals, plants, and structures stable on the surface. However, with a flat Earth, gravity would no longer function in this way, leading to many strange and unpredictable consequences. On a flat surface, gravity would not pull objects straight toward the center of the disk as it does on a sphere. Instead, this force could be unevenly distributed, weakening as one moves farther from the center and even becoming misaligned. People living at the edge of the Earth's disk would experience gravity as a slanted force, pulling them toward the center. This would not only make it difficult to stand upright or move around but would also alter the entire living environment. If gravity were uneven, buildings would struggle to remain upright. All structures, from houses to bridges and roads, would need to be designed to counteract the pull toward the center of the disk. This would not only increase construction costs but also lead to a higher risk of collapse, especially in areas farther from the center. Even water would no longer flow according to conventional rules. Instead of being evenly distributed across the surface, it could be drawn toward the center of the disk, leading to unusual phenomena such as oceans concentrating in one region while other areas turn into barren deserts. This would not only reshape the landscape but also trigger ecological crises, affecting the survival of all living organisms. In a world with misaligned gravity, traveling would be a major challenge. In areas near the center, people might experience gravity as relatively normal. However, the farther they move away, the slanted gravitational pull would make walking or driving extremely difficult. People would have to resist the pull toward the center, similar to continuously climbing an uphill slope. This would not only consume more energy but also reduce transportation efficiency, making economic activities and trade far more complicated. The instability of gravity on a flat Earth would also impact the survival of living organisms. Trees might not be able to grow straight, completely altering ecosystems. Humans might even need to develop new biological adaptations to cope with shifting gravity, such as stronger bones or different ways of movement. In summary, if the Earth were truly flat, gravity would no longer be the simple and familiar force we know. Instead, it would become a strange and chaotic force, causing immense changes in life, the environment, and even the evolution of living beings. Such a world, if it existed, would not only be vastly different but also incredibly challenging for all forms of life. If the Earth were not a sphere but a flat surface, the natural phenomena we are familiar with would change drastically or even cease to exist. From the atmosphere, day and night, and the seasons of the year to astronomical events like solar and lunar eclipses, all would be distorted or disappear, creating a completely unfamiliar world. With a flat Earth, maintaining the atmosphere as it exists today would be a major challenge. Currently, the atmosphere surrounds the Earth because gravity pulls gas molecules toward the center of the spherical planet. However, if the Earth were flat, gravity would no longer be uniform, making it ineffective at holding the atmosphere in place. Gas molecules at the edges of the flat surface could drift into space due to the insufficient gravitational pull. This would cause the air to become thinner the farther it is from the center, reducing the ability to sustain life in outer regions. Strong and unpredictable winds could also occur due to the unstable atmosphere, creating an environment harsher than ever before. The phenomenon of day and night on Earth is currently created by the planet's rotation on its axis, combined with sunlight. However, if the Earth were flat, the division between day and night would no longer function in this way. Some theories suggest that on a flat Earth, the Sun would move in a circular orbit above the surface, illuminating different parts of the disk. This could create a cycle of day and night, but the distribution of sunlight would be uneven. Central regions might receive light more frequently, while areas at the edges could experience prolonged darkness. This would not only disrupt the biological cycles of humans and animals but also cause significant changes in climate and ecosystems. The change of seasons throughout the year is currently the result of Earth's axial tilt combined with its elliptical orbit around the Sun. However, on a flat Earth, these factors would no longer exist. Without an axial tilt or orbit, seasons like spring, summer, autumn, and winter would not occur. Instead, temperature and climate might depend solely on each region's distance from the Sun's movement path. Areas near the center could maintain a stable, warm temperature, while regions farther from the center might remain permanently cold. Solar and lunar eclipses are breathtaking astronomical events that occur due to the unique alignment of the Sun, Earth, and Moon in three-dimensional space. If the Earth were flat, these phenomena could not happen as we know them. Instead, to explain the phenomenon of light obstruction, one would have to assume an entirely different mechanism, such as the presence of an unknown object moving above the surface of a flat Earth. However, this remains purely hypothetical and cannot accurately replicate events like total solar eclipses or partial lunar eclipses as we observe them. The disappearance or alteration of these natural phenomena would make the planet significantly less stable. Life, which heavily depends on the cycles of day and night, seasonal climate patterns, and atmospheric stability, would struggle to survive. A flat Earth would not only change everything we know about the planet but also pose immense challenges to life itself. In summary, if the Earth were flat, our world would no longer be the stable and familiar home we know today. The natural phenomena that have shaped life and human civilization would become irregular or even cease to exist, making the survival of life an immense challenge. A flat Earth would completely alter the geographical structure and environment as we know them. Natural phenomena, from oceans and mountains to the habitats of living organisms, would no longer function according to current laws. These changes would not only reshape the planet's appearance but also pose immense challenges to life. On a spherical Earth, gravity pulls water toward the planet's center, ensuring that oceans, rivers, and lakes are evenly distributed across the surface. However, on a flat Earth, gravity would not function this way. Water, which naturally flows toward the lowest point, could move toward the edge of the disk or even spill over unless some force prevented it. Assuming there were an ice wall, as some flat Earth theories suggest, it would have to be strong and tall enough to contain the massive volume of the world's oceans. However, if this wall were to break, all the water could be pulled into space, leaving the planet dry and incapable of sustaining life. The movement of water would also impact ocean currents, which play a crucial role in regulating the climate. Without currents like the Gulf Stream or the Pacific Flow, Earth's climate would become far more extreme, with freezing regions at the edges and scorching hot areas at the center. Rivers and streams, which typically flow from higher to lower elevations, would be severely affected by a flat Earth. Uneven gravity could cause water to flow toward the center of the disk or the edges instead of following natural basins as it does today. The areas at the edges might become massive water collection zones, leading to constant flooding or the formation of enormous lakes. Mountains, which are formed by the collision and movement of tectonic plates on a spherical Earth, might not exist on a flat Earth. Without the pressure from tectonic plates, the planet's surface could become mostly flat or have only small elevations. This would eliminate many unique habitats, such as mountain forests, plateaus, and the distinct ecosystems they support. A flat Earth would bring significant changes to the living environment of all species. Water, air, and land, the three essential elements for life, would no longer be evenly distributed, leading to drastic changes or even the disappearance of many ecosystems. In areas near the edge of the disk, where water may either accumulate or be scarce, living organisms would face harsher conditions. Some species might adapt and thrive, but many others, especially those dependent on a stable environment, could face extinction. Climate would also play a crucial role in shaping the living environment. Without the stable circulation of temperature from the atmosphere and oceans, the central and outer regions of a flat Earth would experience extreme weather and temperature conditions, making survival much more challenging. Humans, with their exceptional adaptability, might attempt to construct structures or systems to cope with these changes. However, living on a flat Earth would require major adjustments in all aspects of life. Cities might need to be concentrated near the center of the disk to avoid the risks of flooding or water scarcity at the edges. Agriculture, which relies on stable land and water sources, would become much more challenging. The geographical and environmental differences on a flat Earth would not only completely alter the planet's structure but also create unpredictable challenges for life. Oceans could spill over the edges, mountains might disappear, and habitats would become increasingly harsh. Such a world would not only be vastly different but also extremely difficult for life to sustain as we know it. A flat Earth would not only change our understanding of the planet but also have profound impacts on daily life. Technologies such as GPS navigation, telecommunications, and satellite systems all rely on the Earth's spherical shape. If the Earth were flat, these technologies would no longer function as they currently do, leading to serious consequences for how humans live, work, and stay connected. The Global Positioning System, GPS, currently relies on a network of satellites orbiting the spherical Earth. These satellites operate by transmitting signals to the surface and calculating positions based on distances to multiple satellites. This is only possible because the Earth is spherical, allowing satellites to maintain orbits and provide coverage across the entire planet. If the Earth were flat, satellites would not be able to orbit its surface, making the GPS system inoperable. This would mean losing the ability to accurately determine locations, an essential factor in fields such as transportation, aviation, and military operations. Humans would have to rely on traditional navigation methods like paper maps and compasses, causing significant inconvenience in a modern world that has become accustomed to the precision and convenience of GPS. The modern telecommunications system relies heavily on satellites to transmit signals over long distances. Satellites orbiting the Earth help connect remote areas, facilitating data transmission, telephone communication, and internet access. On a flat Earth, without satellite orbits, telecommunications would face many obstacles. Signals would have to rely entirely on fiber optic networks or ground-based transmission stations, which would not only reduce communication speed but also limit connectivity range. Remote or isolated areas that depend on satellites for communication could become completely cut off. The satellite system not only supports navigation and telecommunications but also plays a crucial role in global information management. Earth observation satellites provide data on weather, climate, and natural phenomena. They also help monitor environmental issues such as deforestation, ocean pollution, and climate change. If the Earth were flat, observation satellites would not be able to operate, causing us to lose a crucial source of data for managing the planet. Weather forecasts would become less accurate, making it more difficult to prepare for and respond to natural disasters. Environmental monitoring would also be compromised, increasing the risk of global issues worsening without timely intervention. The loss of satellite-based technologies would have severe consequences for the economy and society. Transportation, ranging from aviation and maritime shipping to freight logistics, would suffer significant setbacks due to the lack of accurate navigation systems. Industries such as high-tech agriculture, resource extraction, and infrastructure development would also be heavily impacted without satellite data to support their operations. Socially, the lack of telecommunications connectivity would reduce access to information and global communication. especially in emergencies. This consequence would not only slow down societal development but also make daily life more challenging for people in maintaining their regular activities. A flat Earth would not only change the way we understand our planet but also create significant challenges for modern life. The loss of satellite-based technologies such as GPS, telecommunications, and global information management would have severe economic, social, and environmental consequences. Humanity would have to rely on more manual alternatives, slowing down development and making life more complicated. If the Earth were flat, the entire field of space science and astronomy would have to be rewritten from scratch. The principles and theories that have shaped our understanding of the universe for centuries would no longer be valid, requiring a completely new explanation for natural phenomena and Earth's place in space. One of the strongest pieces of evidence proving that the Earth is spherical is the images taken from space, provided by satellites and spacecraft. If the Earth were truly flat, these images would either have to be explained differently or be considered fake. This raises a major question about the accuracy of modern technology. The entire aerospace industry, including organizations such as NASA, ESA, and space agencies worldwide, would face skepticism. Missions to explore the Moon, Mars, and research on other planets would also be reconsidered, as they are all based on the assumption that the Earth is spherical. The Coriolis force is one of the clearest phenomena proving that the Earth rotates and has a spherical shape. It affects the movement of wind, ocean currents, and weather phenomena on the planet. If the Earth were flat, the Coriolis force would not exist as we know it. This would require new explanations for how wind and water move across the surface. For example, storms would not have their characteristic spiral shape, and ocean currents would not circulate according to current laws. This would completely alter the climate and living environment, as well as our understanding of weather and nature. A flat Earth would pose a significant challenge in explaining the orbits of planets and other celestial bodies. According to modern science, planets, including Earth, revolve around the Sun in elliptical orbits due to the force of gravity. However, on a flat Earth, gravity and orbital mechanics could not function in the same way. Some alternative hypotheses could be proposed, such as celestial bodies moving in a circular orbit above the flat Earth's surface. However, this would completely alter our understanding of the structure of the universe. From the solar system to distant galaxies, phenomena such as solar eclipses, lunar eclipses, and the presence of stars in the night sky would also need to be reinterpreted. Not only astronomy, but other scientific fields such as physics, geology, and meteorology would also be affected. All formulas, theories, and models that have been built based on the assumption of a spherical Earth would need to be adjusted or replaced. Geology, the formation and operation of tectonic plates, the cause of earthquakes, volcanoes, and landforms, would have to be reconsidered. A flat Earth would not be able to support these mechanisms in the same way as it does now. Physics, theories of gravity, rotational motion, and dynamics would need to be revised to fit the flat Earth model. Meteorology, the distribution of temperature, atmospheric circulation, and global weather phenomena would also change completely. If the Earth were flat, humanity would have to face a completely new reality regarding our place in the universe. The universe would no longer be the three-dimensional space we are exploring but could be understood in a different structure, possibly two-dimensional or an entirely new model. Questions about the origin of the Earth, the formation of celestial bodies, and the laws governing nature would require different answers, potentially more philosophical or hypothetical rather than empirical. If the Earth were flat, the entire field of space science and astronomy would have to be fundamentally changed. The evidence proving that the Earth is a sphere would need to be explained in a completely different way. And all scientific theories related to the universe would be called into question. This would not only overturn our current knowledge but also create a new and challenging perspective on how we understand and explore the world around us. The idea of a flat Earth would not only change how we understand nature but also raise strange and intriguing questions about the planet's edge. What lies there? Is there a massive wall acting as a barrier? Or some mysterious force preventing everything from drifting off? This would become one of humanity's greatest mysteries, fueling curiosity and an unending desire for exploration. If the Earth were truly flat, its edge would be a highly controversial and fascinating concept. People would question whether the edge of the Earth actually exists. If it does, what does it look like? A common hypothesis in flat Earth models suggests that the edge of the planet is surrounded by a massive ice wall, acting as a natural barrier that prevents water, air, and everything else from drifting off. While this idea remains purely speculative, it sparks strong imagination and deep curiosity. If such an ice wall truly exists, is it a natural formation? Or could it be the result of a supernatural force or advanced extraterrestrial technology? In this context, conspiracy theories could flourish. Some people might believe that governments or secret organizations are hiding the truth about the edge of the Earth. They could speculate that beyond the edge is not an empty void, but rather another world, one that harbors creatures or technology far beyond human understanding. Such stories not only capture public interest but also encourage daring expeditions. Private exploration teams, independent research organizations, or even nations might launch missions to uncover the truth. The edge of the Earth would thus become the target of perilous and mysterious journeys, much like the historic explorations of uncharted oceans and continents in the past. Another controversial question is, if the Earth were flat, what would keep everything from falling off the edge? In the spherical Earth model, gravity pulls all objects toward the planet's center. But on a flat surface, this law would not function in the usual way. There could be a different type of gravitational force, or a mysterious energy field, that keeps everything on the surface. However, this hypothesis raises even more questions. Where does this force originate? How does it work? And could it be harnessed or controlled for scientific or technological purposes? The edge of the Earth, with all its mysteries, would also become a powerful cultural and spiritual symbol. Throughout history, humans have always been drawn to the unknown, from the deep oceans to distant stars. If the edge of the Earth truly existed, it could be seen as the final frontier for human exploration, inspiring art, literature, and religion. Some people might believe that the edge of the Earth is a meeting point between the physical world and the supernatural, or a gateway to another dimension. Myths, legends, and rituals related to the edge of the Earth would emerge, becoming an integral part of human culture. Exploring the edge of the Earth would require enormous scientific, technological, and financial resources. Scientists would need to develop new tools and methods to reach this area, while governments and organizations would compete for control over the edge, much like how humanity has historically disputed territories on land or at sea. On the other hand, if the edge of the Earth were proven to be real, it would cause a major psychological and societal shock. Traditional concepts of the Earth, space, and the universe would be challenged, forcing humanity to redefine its place in the larger scheme of existence. If the edge of the Earth existed, it would become one of humanity's greatest mysteries. It would not only change our understanding of the planet but also spark endless curiosity, creativity, and exploration. Questions about this edge, how it was formed and what it means for the universe, would not only transform science but also reshape human culture and thinking for centuries to come. Even though the flat Earth hypothesis is purely a fictional idea, it still sparks curiosity and challenges human imagination. In reality, the spherical shape of the Earth has been proven through numerous experiments and scientific observations. However, asking, "What if?" allows us to gain a deeper understanding of the unique planet we live on. What do you think if the Earth were flat? Share your thoughts.